Hi everyone, I believe you're all doing fantastic. It's such a joy to join you in your homes once again to learn CAD. For today's session, we'll be learning about assemblies. To assemble something simply means putting things together. So in the previous tutorials, we learned about how to create various components and then models or bodies that we will call spare parts. Take, for example, the spare gear that we created that we use for learning circular patterns. It could be the spare part of a bigger machine that you are creating. In Fusion 360, the tool that can help us to assemble the various components is called joints. So we'll be using the joints to assemble this hammer with a sliding plastic handle. We'll use it to look at the basic type of joints, and then we'll shift to this gearbox where we will analyze the motion between the various types of gears that we have on this panel. We will also learn about the various types of motions that we can establish between the various joints that we will be creating. We will also learn about how we can limit the joint motion of some of the gears on this assembly. We will as well learn how to link the motion of, for example, this spare gear with this spare gear so that when I am rotating one of them, the other can also move as well. Now, a quick way we can apply this gearbox is in building a windmill. Let's say we want the wind to rotate this big gear through a very short distance for us, and we want to multiply the distance through which this gear moves by 4. We can have this system of gears that multiplies the distance through which this smaller motor moves by 4 using this arrangement of gears which are in a ratio of 1:2:4. To create the hammer, I'll create a new tab, and then I'll start off with a 2-point rectangle of dimensions 120 by 30. And then I'll use the dimensioning tools to modify the dimension to 120 by 30 millimeters. I will then extrude this to a height of 30 millimeters, followed by using construction lines to locate the middle of this rectangle by drawing 2 diagonals. I will then follow by drawing a center point circle at the middle of the diagonal with a dimension of 24 millimeters. I will then extrude cut this rectangular prism by cutting through the circle through a distance of minus 30 millimeters. This will now result in something like this. I'll now apply fillets on all the 8 sides of the rectangular prism by holding on to the control or the command button and selecting all the edges or faces. The thickness of my fillet will be 3 mm. I will now create the handle of the hammer by using the pipe tool. But before I can create the pipe, I need to create a line that the pipe will follow. So I'll create the handle also on the top plane. So I'll begin by drawing a line of height 300 millimeters, and then I'll come here to solid, click on create, followed by pipe, and then I'll click on the profile that I create, and then I'll make the diameter of the handle to be 24 mm, which is the same size as the hole inside this, and then I'll make the thickness of the pipe to be hollow and be of a thickness of 4 mm, followed by OK. So I'll get something looking like this. Now the next thing I'll do is to create plastic handle cover of the handle. To do that, I'll use the cylinder feature and then I'll click anywhere on the bottom plane and then draw a cylinder of diameter 27, followed by making the height 100 millimeters. I'll then use the shell tool to shell this guy to a thickness of 3 mm, and then that will be it. The next thing I will do is to change the appearance of the various elements of this hammer. But before I continue, I would like to change the names of the various components we have here to different names so that we can identify them going forward. So I'll call this hammer body. I'll call this the hammer handle, and then I'll call the last one the handle cover. Great. Now the next thing I'll do is to change the appearance of the various items bodies I've created here before I assemble them. So I'll press on A, followed by changing this one to steel cast, and then I'll change the color a little to this wine color, and then I'll use the same color for the handle as well. I'll now change this plastic handle to ABS white. The next thing I'll be doing now is to create joints between them. Now, to be able to assemble this into a hammer, let's explore the assemble menu. Now, there are a number of items over here. The first one here is to create component. Create a component. You can use this to create a new component of your assembly. Now, you notice that in this modeling that we have done so far, we are having 3 different bodies. To be able to assemble something in Fusion 360, you need to convert your bodies into components. The main difference between a body and a component is simple. If you have this body is constrained to the geometry, this plane that we are using over here. So if, for example, I want to move it, I'll be moving it with respect to this plane. But if I convert it into a component, the Fusion 360 will now treat everything which is part of this as a single unit, treat this handle as a single unit, treat this as a single unit, etc. So I can create multiple copies of all of this, and it has nothing to do with the geometry of this current plane. So we'll convert all of this into components by clicking on bodies and then right-clicking and then selecting convert to components. And then you'll be having these 3 new components created for you over here. Now, the next thing we'll do is to create joints between them. So we'll create a joint between the handle and then the handle cover. Now, when you want to create a joint, all you are trying to say is you want to select a point on the geometry of the figure where something meets something. So the joint marker is this icon that when you are moving the cursor, it begins to show on the various parts of the bodies or the components you are having over here. So if, let's say, I put my marker up here and I want my joint to be created down here, all I have to do is to click and press on Control and keep moving my cursor till I get down here. So I can click here and then followed by this place, and you see that the handle will automatically slide from where it was to the handle. I am okay with it, so I'll click on OK, and then I am done assembling this one and then this one. Now, the next thing I will do is I would like this hammer to not move, and I don't want the handle to come off this handle. So there are 2 things I'm going to do. The first one is I am going to click on Assemble, and then I'll click on Rigid Group. when I click on rigid group, all that it means is this handle and this handle cover are one single unit and they move together. So I'll click on this one, click on the plastic side, then it will ask me a question. Do I want to constrain the following components? And I'll say yes. Now the next thing I will do is to ground the hammer body, because we want the hammer body to be something that is stationary for the handle to be assembled onto it. So I'll come here, click on the hammer body, and then I'll click on ground. What that simply means is I can no longer move this hammer body around, but I can move this guy around very easily. So I'm now coming to create a joint between this guy and then this one. So I'll click again on assemble, create joint. Now, when you are assembling, you'll be getting a lot of these prompts. It says some components have been moved. Capture this position or continue with previous position. You can either capture the position if you want to capture the position, or continue if you don't want to capture the position. So I'll capture the position, and then the next thing I'll be doing is to create a joint on top of this hammer, like this. Like this, and then I'll follow it up by creating another joint right on top of this. Good. So you notice that the handle moves to come and snap fit at this point, and then all I have to do is to press on OK. So this becomes our hammer. Now, there are a number of things we can do. We can edit the joints that we have created by coming here and then clicking on the first joint which we created between the handle and then the handle cover. You can right-click on it and then click on Edit Joint. And then there are a number of things you can do here. Let me go to the joint motion. I can make this handle to be able to rotate around, handle cover to be able to rotate around the handle by clicking on the revolute. Or I can make it to be a sliding assembly between them, where the handle can slide freely on the handle of the hammer. Or I can make it cylindrical, that is, it will be able to rotate on two axes. The axis that is at the bottom of this, and then the axis along the body of the handle. Or I can use the pin slot motion, which you can see over here, or the planar motion, which you can see over here as well. Or I can give it kind of like a ball bearing motion by using the ball motion joint. So I'll leave it at revolute for now, and then I'll click on OK. Now, to create the system of gears or the gearbox that I have here, I'll be illustrating how you use the type of joint called the as-built joint. When we were creating the hammer, what we did was all the various components were lying at different parts of the plane, and we just created joints between them. With the as-built joint, we will need to move all the various components to where we want them to be before we create the joints between them so that they can interact with one another. So if we want to create this gearbox, we will first of all need to create the different sets of gears, followed by the platform on which they are lying. After that, we will move all of them to their various positions so that the teeth can intertwine with each other before we can be able to create the motion between them. So to start, I'll create a new tab, and I'll go the old school way by creating all the gears differently and then moving them into the assembly like we do when we are using SolidWorks. What I'll do is simple. I'll click on the data panel, and then I'll go to my home directory, and then I'll create a new project. I'll call it Gearbox. After that, I'll open the new project I've created, and then I'll create a new folder in it called the gears. I'll then open this and then create the different gears into it. We'll be using the Spur gear tool that we used the last time. So all you have to do is to click on Tools, and then you click on Add-ins, followed by the Spur gear command, and then you have a dialog looking like this. Now, we are coming to create 3 different gears, and we want these 3 different gears to be in a ratio of 1:2:4. So we will need to modify these settings here so that the gears can be in that particular. To determine the gear ratio, I will only be using the number of teeth, which is this one, to determine the ratio. So I want to create 3 gears of teeth ratio 6:12:24. So the first gear I'll create will be having 24 teeth. The second one will have 12 teeth, and the last one will have 6 teeth. So 6:12:24 will result in a gear ratio of 1:2:4. So I'll leave the 24 here like this, and then I'll change the gear thickness from 12.7 to 40 millimeters, and I'll leave everything else like this, and then I'll press on OK. So the resulting gear now looks something like this. I'll click on Appearance, and then I'll change it to Steel, and then I'll double click on the steel to give it some beautiful red color like this, followed by Done. The next thing I'll do is to create a new tab and then create another gear of number of teeth 12. So I'll click on the tools once more, followed by add-ins, followed by scripts and blah blah blah, followed by Spur gear, run. I'll leave every setting like the way it is, and then I'll change this one to 12, and then I'll change the gear setting once more to 40 mm, and then I'll press on OK. I'll then click on A for appearance, use the same material, double click on it, change the color to something looking yellow like this, followed by close. And then the next thing I'll do is to create a new tab as well. Repeat the same thing with the gear having 6 as the number of teeth. So I'll click on run once again. I'll maintain the same settings, change the number of teeth to 6, and then I'll change the gear thickness once more to 40 mm, followed by appearance, the same material, and then I'll double click here, make this guy green, followed by done. So I'll save this guy like this, and then I'll call it small gear, followed by save, and then I'll come here as well, save this guy, I'll call it medium gear, and then save, and I'll come here, and then I'll press on save once more, and I'll call this one big gear, followed by save. Now you can wait for it to synchronize into the cloud, and then you can actually close the various tabs because we will no longer modify the gears. The next thing I'll do is to create a new tab, and then I'll create the platform on which the 3 gears or the 4 gears will be sitting, and then I'll move the gears in as different components. So I'll click on save, and then I'll call this one the gear base, followed by save, and then I'll click on sketch. I'll select the bottom plane, and then I'll draw a 2-point rectangle. I'll draw a 2-point rectangle of dimensions 400 is to 500. I'll use the dimension tool to change this to 400, followed by this side to 500 millimeters. I'll now apply fillets of radius 30 mm on all the 4 sides of my rectangle to make it look something beautiful like this. And then I'll press extrude, and then extrude this to a height of 40 mm on the Z axis. So the result looks something like this. And then the next thing I'll do is to press on A for appearance, use the same material, move it here, double click on it, and then I'll give it a slight, I don't know if this is purple or, well, let's call it purple, and then I'll press on OK, and then I'll click on close. Now, the next thing I'll do is to convert this platform into a component. It is still a body, and it is still restrained to this geometry. So all I have to do is to change this, the name of it, from body 1 to base, and then after that I'll right click on it, and then I'll press on create component from body. So you can see that at this point this gear, the base now becomes a component, and it is no longer a body. The next thing I have to do is to move the 3 different gears I created onto this platform. But because we know that this platform is raised 40 mm above the origin of the Z axis, we will need to offset that when we are moving them onto this platform. So once again, with the as-built joint that we are coming to create between these 3 gears, all we'll be doing is to move them onto the position on the base, position them exactly how we want them to be, and interact with each other before we create the joint between them. Let's start with the big gear. So I'll just grab it and then move it somewhere here, and then I'll look out for the prompt that will come. Now, when you want to move or copy any model onto the other, there are a number of motions that you can have between them. The first one is the translation motion, which is like moving along a line. The second one is the rotation motion, and then the next one here is the point to point, and then the point to position. So the first task I want to accomplish is to raise this first component above the base. That will be an offset of 40 mm on the Z axis. And then the next thing I'll do is I would like it to come and then position itself somewhere around here. So I'll click on the translation motion because I know that it is on the face of this component. So I'll use the various arrows here, this one and this one, to move it to the position that I want it to be. And then I'll use this guy to move it here like this. And then if I am satisfied with it, I think I made a mistake. I actually moved it on the Z axis instead of on the Y axis. So I'll change the Z axis here back to 40, and then I will carefully click on the Y axis and then move it to the position that I want it to be in on this base. So you can see that the Z axis is still 40, the Y now is 375, the X is now 420, which is good. And then I press on enter. So the result of this movement is something like this. You can still see that something is hanging somewhere at the moment. I think this thing is above this base by roughly 40 mm. So I can once again click on the move or copy tool, click on this body, and then, component, click on this component, and then I'll move it through a distance of minus 40 to see if it will sit exactly on my base. So like this. Now the next thing I'll do is to move the second gear onto the platform. So I'll click here, drag it, and then bring it somewhere here, like this, and then I'll wait for it to appear. So I can move it to a height of 40 mm like I did for the previous ones. Move it somewhere here like this. Click on this axis as well. Move it here. And then my next goal is to see if I can make the gear to sit comfortably and interact with this one. So I'll still use the move. All right, so I think I have to move in smaller steps. So I'll make this one 315 and see what will happen. Good. I think I should make it 316. Good. And then you can clearly see that I have a perfect interconnection between this gear and this gear. And all I have to do is to press on OK. So once again, with the as-built joint, you have to position the components at the position that you want them to be in before you can be able to do your assembly. The last thing I'll do is to move in the small gear here and then move it like I did earlier. So I'll move it 40 millimeters on the Z axis, and then I'll move it here this way, and then I'll now go on the Y axis, and then I'll try and see how best I can connect this gear and this one together. So I'll move it here a little bit. So I'll move it here a little bit. Let's see, 5 mm, 6 mm, 7 mm, 8 mm, 9. All right, so 9 is kind of like looking good. And then I'll bring it a little closer. Let's see, 1 mm. And I think I got a good interconnection now between this gear, and then this gear. And then I'll press on OK to confirm. All right, so I have all my 3 gears arranged in position. The next thing I'll do is to create the joints between them first, followed by the motion between them. Now, before I can create the joints and motion between this system of gears, I'll need to determine what is stationary and what is moving. The base is stationary, and then the 3 gears are moving. So I'll click on the base, right-click, and then ground it so that the base becomes stationary and then the gears are mobile. After that, I'll create the as-built joint between the gears and then the base, followed by the motion definitions between them. So I'll click on Assemble, followed by as-built joint. I'll capture the position, and then the components in my joint are this guy and this guy. And then I have defined the type of joint to be the revolute type of joint. So I'll need to specify the point where it is going to be revolving. So when you do that successfully, you see that the gear begins to animate itself. You can animate it over here, change the axis of rotation over here as well. And then if you are satisfied, you press on OK. So I'm going to do the same thing for these other 2 gears. So I'll click once again on as-built joint. I'll select this component, that component, and then the point where it snaps is the middle of this circle. And you notice that this gear also begins to animate when you do that. And then the last one I'll do is to click on Assemble, as build joint, click on this guy, click on my base, and then I'll let it snap to this point, and you begin to see the smaller gear also begins to rotate, and then that is it. Now, my goal is to now make these gears work with one another. They should be able to interact with one another. So I am now coming to link the motion between the three gears I have created over here. So I'll come here once again to Assemble, and then I'll come to Motion Link over here, and then I'll capture their positions once again. And then I need to select the joints that I want to link their motion. So I'll link this one and this one's motion first, followed by this one and this one's motion. Now you can clearly see that this one is moving counterclockwise to this one. So I need to change the direction. So I'll change this one to minus, and then you see that they are now beginning to interact with each other. So I'll leave this guy at -1, which means that if this guy rotates through 360 degrees, this one now moves through 360 degrees. But that's not what I want, so I'll change this one to 2, so that when this one rotates once, this guy will rotate twice. So this is a perfect interaction between the two gears I have created over here, and then I'll press on OK. My next job is to link the motion between the yellow gear and then the green gear. So I'll click once again on the motion link, select this joint and that joint, and then I think the same thing that happened repeated itself again. So I'll change this one to -1, and then I'll change this one to +2 and see what will happen. So you notice that all the three gears are now interacting with each other in a very beautiful way. So you can actually click and hold on your mouse button to see how they move. And when you are satisfied, you can now finish your assembly. The next thing I would like to show you is how you can do a motion study. A motion study is you want to automate the movement of these joints you have created and see how they interact with each other on a time basis. So I'll click once again on Assemble, and then I'll click on Motion Study. Now when I click on Motion Study, all I have to do is to select a joint, and then when I select the joint, I can learn more about the motion between this joint and then this joint and that joint. So to do that, I'll need to select this joint for my motion study, and then I'll click on play and see what happens. All right, so nothing happens. So I can come here, and then what I'll do is I'll change this one here to 360 degrees. So all that simply means is I want this gear to rotate through 360 degrees for me to see what will happen. Now the steps here are the number of times that this gear will now rotate. All right, so let me click on the play button here and see the motion that will happen. So the motion study can help you to study the various links between the components you have used for your assembly. So I'll make it a loop, and then I'll press on play once more, and then you begin to see that my motion begins to repeat itself, and I can clearly see that if this gear rotates once, this gear will rotate 4 times. So I'll press on OK, and then I can save it. I can change the joints and then the motions over here when I am done. I can come here once again, right click on this, edit the motion, and change it to something that I like over here. And then I can also come to the joints, look at the 5 different joints I have created here, and then modify all of them according to how I like. Now, to finish this lesson, I would like to show you how you can limit the joints. So you can right click, for example, on this joint, which is the first joint over here, Rev 1, and then we want to limit it to from 0 to 300 degrees. So you can right click on this, and then you change it from 0 degrees to, for example, 300 degrees, so that it can only rotate from here and then stop here, and then you press on enter. So if you right click on it and then you grab it, you can only move it through 300 degrees, and then it will stop at the limits you have set for it. Thank you so much for partaking in today's video.